So good morning to all of you. So today let us discuss the basic instruction types which were available in computer organization and architecture. So in this we know that each and every instruction of the CPU will contain specific information, or let us say fields, so which are required to execute, and these information fields of instructions are called as elements of instruction. So what are those elements? Let us see into three different or four different classifications. The first element can be, let us say, opcode, and next can be source or destination operand. If you see this one, this R1 can be source or it can be destination. Again, this R2 can be source or destination. Similarly, R3 also can be a source or can be a destination. We'll come back to these classifications later. Before that, just let us have an idea about operation code. So this operation code, it's a field in the instruction which is going to specify the operation to be performed. Means what operation you have to perform. Like it can be add, it can be subtract, it can be multiply, divide. See this one. So this add is there here, right? So this is like an operation code that will act like an operation code. So that's why which operation it has to be done is being specified by the binary code. So that's why the name is given there as operation code, or it can be simply also called as opcode, opcode. So second one, source and destination operand. So as I told you, so this R1, R2, R3, any one of them, they can be either source or they can be either destination. So source and destination operand. The source and destination operand field will directly specifies the source address, or it will specify the destination address. It can be any one of those. It can be either source or it can be either a destination. Okay, next. So we have source operand address and destination operand address, and next instruction address. So these are the things we have. Let us say, for example, this one can be source address, and this R3 here can be a destination address. Okay, and the next instruction address can be something like R2, something like that. Okay, so let us go into the technicalities. So what we try to understand now today on basic instruction types. As you can see here, there are different classifications: 3 address, 2 address, 1 address, and 0 address. You see this one here, R1, R2, R3, 1, 2, 3. There are 3 addresses. Whereas R1, R2, only 2 address. Only one address. It can be a B register or it can be carry register, whatever. Generally, we wrote it as M. The content of M will be taken, one address. Whereas you see this one here, there is no address. So based on the number of addresses what we use here, we are going to categorize into types. So three address, three address instruction, two address instruction. Like you see the number, 3 here, 3, 2 here, and 2. One address, so one address. Zero address, so that's what. Okay, let us go into the details about 3 address instructions. Okay, so take an example like add a comma b comma c, or add, see this example which is there highlighted in red color, add r1 comma r2 comma r3. So what is the meaning of this one? The R3 is the destination where we are going to add R1 and R2. Finally, the result is stored in R3. If you understand this, this add is like opcode. R1 is like your source. R2 is also a source, but it can be called as next instruction address, let us say. And this R3 is like your destination. Okay, that we got clear with. Now in the example where this R1, R2, R3, all three of them are variables. All these three, R1, R2, R3 are what? Variables. So these variables names can be distinct. It can be A, B, C, R1, R2, R3, R3, R2, R4. So it can be any of those names. Okay. In this instruction, the operands, so these are called operands, right? As we discussed earlier, these operands, R1 and R2 are source operands, whereas R3 operand is the destination operand. R1 and R2 are source operands, R3 is the destination operand, and the add instruction is the operand. This add instruction is also called operation code, or it's also called as opcode. Okay, so this how this three instruction is going to be understood. Now further, if you go into two address instructions, in these two address instructions, it can be represented symbolically as example of add R1 comma R2. Okay, where this add is your operation code, R1 will act like a source and R2 will act like destination. Okay, which means let us say for example R1 value is 4, R2 value is 5. So this R1 value is 4 and this R2 value is 5. If you add these two numbers, actually R2 value is 5, right? But when we compute the instruction 4 plus 5, it is 9, that will be replaced by the previous R2 value, is going to get replaced. Okay, so that's how this operand two address instructions will be varied. Whereas if you go to one address instruction here, you see this one add m, it was there, add m. So what is that? It can be like add b. B means what? It's like accumulator A register and B register. So add b if you give, or in general we wrote is m. So add m if you give, it's going to add the value of this, the content of this m register. It can be any of the memory register, it can be B register, whatever. That content will be added along with the accumulator value. AC is called as what? Accumulator value. And then that will be replaced again in the accumulator. So this is how this one address instruction is being useful. Even though it is being given with single instruction, but in the back end, the accumulator is also involved in the functionality of this. Okay, and moving on to the fourth type, zero address instructions. So zero address instructions, in these instructions what will happen is the locations of all the operands are defined implicitly. Okay, and these such instructions are found in machines that store operands in a structured called as push down stack. So this is going to be performed, the zero address instructions is being uh, performed based on zero address instructions are based on push down stack. Okay, so with this we can able to understand that the instruction with only one address will require less number of bits to represent it, which means we need to can represent that very easily. That will be very easy for us compared to three registers or two registers. Okay, so therefore what we can say, to access the entire instruction from the memory, it will take lesser space, it requires lesser address, so it will be much more easier compared to the others. Okay, so that it will have the lesser execution time compared to other instructions with minimum memory involved. Okay, so this is how it is. If you look at the next one, risk instructions, if you look here, these risk instructions will have lots of registers. So risk means what? Reduced instruction set computing. So this risk means what? Reduced instruction set computing. For these instructions which requires a lot of registers, along with that the memory is restricted to load and store, which means when we are trying to load it or when you're trying to store it, that confined with the limitations of the memory. If you take an example of the instruction, see here the 3D view of this. If you take an example of this instruction, which instruction is being divided into opcode and operands. These operands can also be like addresses. Say for example, this is an instruction, add R1 comma R2 is an instruction. In this, what is opcode here? Add is an opcode. R1, R2 are operands. So if you also use the memory like add 6 comma 4, let us say if you use direct address memory, then instead of operands we also have addresses. Okay, so in the risk instructions we have the instruction in this manner. The instruction initial part will be opcode, as seen the example here. This opcode is like this. It can be add, multiply, subtract, divide, okay, and it can be anything, any of the opcode what we have here. And this can be operand or operands. So here you see only one was there, so we can call it operand. We have multiple here, so we call it as operands. If sometimes you don't use the registers, we use the addresses, then these operands will be either replaced by this addresses. So this how the addressing type, basic instruction type we have here. Okay, if you see an example of this one, how do we evaluate this? If you want to evaluate a plus b into c plus d, so we need to perform a plus b initially, addition, and perform addition of c plus d, so that we get some value of a plus b here, and we get the addition value of c plus d. Then we are good to go with the multiplication. That's what we completed this in 3 address instructions. You see this for example here, add. We are trying to add a and b. Let us say for example a and b are added and stored in r1 register. So this complete sum of this will stored in r1. You see c plus d, we are trying to add c plus d, and the result is stored in r2 register. And similarly, finally we are trying to multiply this r1 and r2, and we are trying to store it in x. So finally x will have the result. So this way we can able to understand the basic instructions what we have available in the computing. Okay, so we'll see some more interesting things in the next session. Thank you.